Module 10, Lesson 4 covers interquartile range and box plots, also known as box and whisker plots. Now this is one of those concepts that if you don't learn the vocabulary, it's going to be extremely difficult. But if you learn the vocabulary, it's going to be stupid easy. It all comes down to whether or not you take the time to learn your vocabulary terms. Our textbook says this is a single day lesson. There's a mere 10 slides involved in it. So, what I say is supposed to be pretty dang easy if you take the time to learn your vocab terms. The life expectancy of animals is an average lifespan of that animal. Predatory cats are part of the animal family Felidae, we'll call it Felidae, which is a large variation within the group's life expectancy. For many biologists, it is important to find out more about this variation and study it. The variation of the data set describes how the data is spread out. Describe the variation of the data set. How would the variation of the data set change if there were a predatory cat added whose life expectancy was 7 years? What could we use to describe the data set? These are some of the things we're going to be learning about in this lesson. We're going to be using our box and whisker plots to describe the data, and also we're going to be looking at what happens when you throw that outlier like a 7-year life expectancy into it. How does that skew the data one direction or another? Now we're going to start off this lesson with a couple of definitions, the first of which being measures of variation, which are values that describe the variability or spread of the data set. And we're going to make that green. They describe how the values of the data set vary with a single number. One measure of variation is known as the range, and the range is known as the difference between your greatest and least data values. That's something you should know by this point. And then select the button to find the range of the data set below. So we go from 0 to 8. So the range, that's nothing more than 8 minus 0, which is 8. The range is the difference between your least and your greatest data values. From there, you can scroll down, and if you really want to, plug in an 8 right there. It's going to give you a happy sound, and we can move forward with our instruction. Another means of variation is interquartile range. Before you can find this measure, you first need to understand and find your quartiles. Quartiles is defined as values that divide the data set into 4 equal parts, like quarters. You have 4 quarters in a dollar. You have 4 quartiles on your data set. Your first quarter, otherwise known as Q1, is going to be the median of the data values that are going to be less than the median of the entire data set. The third quarter, otherwise known as Q3, third quartile, otherwise known as Q3, is going to be the median of the data values that are greater than the median of all the data values combined. And then finally, the median is also known as the second quartile, or Q2. Now we're going to move through some steps to figure out how to actually do all this. Our textbook has given us this set of data starting at 0 and going to 8, and then the first thing they want to do is pick the middle, which is going to be between 3 and 4. 3 and 4 are your 2 middle values, and when you average them, you get 3.5. So your median, otherwise known as Q2, or your second quartile, is going to be 3.5. Next, we need to find the first quartile and the third quartile. We're going to take a look at the lower half of our data set, which goes from 0 to that 3 right there. And in that 0 to 3, we're going to pick the middle. And once again, the middle lands between 2 data values, 1 and 2. And when you average that, you get 1.5, which means that your quartile 1, or Q1, is going to be 1.5. Finally, we're going to take the other set of data values, the other half, which is going to go from the 4 to the 8. We're going to look for what's in the middle of those, which you're still having an even set of data values. That means that Q3 is going to be the average of the 6 and the 7, also known as 6.5. So we have all of our data values. Your first quartile is 1.5, your median is going to be 3.5, and your second quartile, or your third quartile, that's going to be 6.5. The fourth, let's see, the median divides the data into two halves, the quartiles divide the data into fourths, and each fourth represents 25%. That's 1/4 of a data set, and that's all the more we need for that slide. Now our next definition is interquartile range. The interquartile range is defined as the distance between the first and the third quartiles in the data set. So we're going to highlight that. To find the interquartile range, you subtract the first quartile from the third quartile. That's all there is to it. The interquartile range represents the middle half or middle 50% of the data. The lower the interquartile range of the data set, the closer the middle half of the data is to the median. So, if you go back and look at what we did, we had the first quartile was 1.5, the third quartile was going to be 6.5, and your interquartile range, well, that's going to be the distance between them. 6.5 minus 1.5 is going to end up giving us, 4? Nope, 5. It's going to end up giving us 5 for our interquartile range. So right there, we're going to type in our 5, check our answer. That's all there is to it. The interquartile range, it's a lot of scary words, but it's just subtracting the first quartile from the third quartile. In example 1, we're looking at the approximate maximum speed in miles per hour for a variety of different animals. And you can see the spider, he's going to lose that race. I hope he doesn't get stepped on. The average interquartile range of the data describe how the data varies. So we're going to take and look at the house cat through the cheetah. That's all the values that we're going to be looking at. And house cat, cheetah, elephant, lion, mouse, and spider. That spider's kind of slow. We're going to move from there. And first thing we're going to do is note that the greatest speed is 70 miles per hour. And the least speed is 1 mile per hour. So to find out the range of our data set, all we have to do is take 70 minus 1, and that's going to give me 69, which is going to be the range of the entire set of data. Part B of this problem says describe the variation using the interquartile range. And the first thing we have to do for that is order our values from least to greatest. So we're going to have a 1, an 8, a 25, a 30, a 50, and a 70. There's our values from least to greatest. And then we're going to take and find the mean of the two middle values. My two middle values are 25 and 30. 25 plus 30 is going to be 55. 55 divided by 2 is going to be 27.5. Check that. That's going to be the mean of those. It's also going to become the median of the entire data set, also known as the second quartiles. Move it along from there. We're going to take and, we got the median is 27.5, which is what we came up with. Let's see what else they want us to know. The first quartile is going to be the median of the lower half. And if you look right here, the median of the lower half, it's that number. It's going to be 8. And then the median of the upper half, that's going to be 50, which is going to go right here. We're going to hit check our answers, and those check. It really is that simple. So the first quartile is going to be 8, and your third quartile is going to be 50. Next thing we're going to probably find, yep, there you go, the interquartile range, which is going to be our 50 minus our 8, otherwise known as 42. So our interquartile range between those speeds is going to be 42. And I think that's, oh, no, here we go. So the spread between the middle 50% of the data, that's 42, otherwise known as the interquartile range, which means the middle half of the data varies by 42 miles per hour. That's all there is to doing these. Now it's going to be your turn. Go ahead and pause the video again and work on extra example number 1. Alright, I've taken my data set and I've put them in order from least to greatest, and the first questions that they have for us is they want to know what is the range going to be. The range is of course going to be the greatest data value minus the least data value, which is going to end up being, let's see here, let's stack them on top of each other to make that math a little simpler because my brain's getting tired. I'm going to do some borrowing. 11 minus 6 is 5. 6 minus 5 is 1. So our range is going to equal to 15, which we're going to jump back over to the textbook and put in 15 right here and check. That part checks. Next, it says describe the variation using the interquartile range. That means I need to find the median, I need to find quartile 1, and I need to find quartile 2. So to do that, we're going to jump back over here, and the median is going to be, there's 10 data values, so it's going to be right here between data value 5 and data value 6. But here's the cool part. I don't even have to find that data value. All I have to do is take and from there, acknowledge that's the middle, and from here I can find quartile 1, which is going to be 48, or it can be 58, and then quartile 3, that's going to end up being 64, because those are going to be the middle of the upper and the lower half. So to find the interquartile range, I'm going to drop my pen there, the IQR is going to equal to that 64 minus the 58, which is also going to be known as 6. So I'm going to jump back over to my textbook page. I'm going to say that there's 6 cans that are in the interquartile range. That's all there is to it. Pretty simple, right? Sadly, this lesson's taking a little longer than I thought. It's going to end up being over 20 minutes total, I believe. So we're going to go ahead and stop the video right here and come back in a little bit to work on part 2, where we're going to start constructing box plots. I'll see you in part 2.